Thank you for joining me in this YouTube session on large language models. So in this session, I'm going to reflect learnings from a recent large language model focused machine learning summit. During this summit, I also gave a presentation. My talk was about retrieval augmented generation. For those of you who are interested in retrieval augmented generation in particular, you can refer to my other YouTube video. The conference happened in Beijing in October 2023. A similar conference happened in April. So in the April session, people were still talking about ideas and their visions about large language models. But in October, we see a lot more applied work and reflections from personal experiences. So we can witness a rapid progress in large language model area here in China. In this overview, I'm going to categorize the work into three buckets. The first bucket is model, including model training journey, SFT, and reinforcement learning from human feedback, as well as the model interpretability. The second bucket is inference tooling. I'm going to skip over the training and the inference infrastructure and focus on orchestration. The last bucket is applications. There is a number of different applications. So one application of particular interest is productivity. The second is the interplay between search and large language models. So even for retrieval augmented generation, there were 5 dedicated talks. A lot other talks also refer to retrieval augmented generation as well. Then I'm going to talk about Copilot and agent, and I will skip AIGC. Now let's first look at modeling. A number of companies reported their model training journey, including Zhipu AI and Baichuan AI. Throughout this presentation, I will refer to a number of different Chinese companies. For people without the background of Chinese internet companies, it may be a little bit foreign, but I'll try to de-emphasize on the background information needed and focus on the technology itself and learnings. Now let's first look at model training journey. As I mentioned previously, a number of different companies reported their journey training large language models, one of which is Zhipu. Zhipu originated from a university lab in Tsinghua University. They are one of the early pioneers in large language models. They have open sourced their 130 billion parameter GLM model, which is a bilingual model on GitHub. So you can do a search on GitHub and try out their model. Their training journey was an 8 months journey from December 2021 until July 2022. Throughout this journey, they experienced numerous challenges, including algorithmic challenges as well as engineering challenges. They experienced gradient explosion, layer norm instability, and issues when trying to recover from a previous state. For engineering, one unique challenge was they were basing their training framework on a hybrid GPU cluster. Instead of just NVIDIA A100 cluster, they had clusters from some local vendors, which make it even more challenging to train the model in stability. Also, frequent hardware failures. So the entire training process needs to be resilient to hardware failures. Another example was Baichuan, which is a local company with years of experiences in NLP and search. So they were relatively quick in training their 53 billion parameter model from April until September 2023. They have open sourced smaller versions of their model as well. As we know, after model pre-training, we typically go through supervised fine-tuning and reinforcement learning from human feedback. Interesting insight here is we can develop both a reward model and a feedback model. The reward model can be used to train samples, and feedback model can be used to optimize the samples. The rationale here is the data quality is the key. For this, we need the correct data. We need difficult or hard cases, and we also need diverse data. There were research showing when you have high quality data, even with a smaller amount, the model performance might still outperform the model trained from messier data. To give feedback on our data, we can either rely on the environmental feedback or we can rely on human preference. By environmental feedback, I mean in certain applications, you can get objective feedback from the environment. For example, in coding examples, we can send the coding examples to debugger, and the ones which can successfully debug are the positive cases. In most cases, when we don't have environmental objective feedback, we can rely on human preference. So that's a time we need to align with human preference. The reward model can give a preference on different cases, which are the preferred answers, which are not. Feedback model can give guidance to how you can improve this answer. For example, if we are looking for Jay Chou's most favorite song, and a first answer given by the large language model is it simply lists three songs without telling us which one is most popular. And then the feedback model can point out that this answer doesn't provide any popularity of songs. So by incorporating this feedback, a better answer would be pointing out the name of the most popular song. That's 稻香. This is how the reward model and feedback model works. So one can give us a preference of different samples, allowing you to filter the samples. Another is to give feedback and point to directions of how you can improve over the current answer. So we can take a unified view of data and alignment given this observation. So basically, the reward or the feedback model can be incorporated as a critic. And this critic allows us to choose and pick the data. So the high quality samples will be incorporated into our database. And it can also leverage reinforcement learning from human feedback. So we can use a previous large language model to generate the answer, and then the critic will give feedback so that it will generate an improved answer. Another interesting observation is in mathematical reasoning, often our feedback is on the final answer. So basically, suppose we are trying to solve 2x plus 7 equals to 15. If the answer is x equals to 89, clearly it's a wrong answer. But a preferred feedback loop would be to look at individual steps. So there are 4 steps here. From step 1 to step 2, we simply move 7 to the right-hand side, which is correct. But in the next step, going from 2 to 3, we state 2x equals to 16, which is clearly wrong. So by providing intermediate or stepwise feedback in the training data, we can allow the large language model to better learn the reasoning. Now let's take a look at model interpretability. Model interpretability is challenging with large language models. For one thing, large language models may have billions of parameters, so it can be extremely difficult for humans to understand the meaning of these parameters. For another, even if we take a prompt-based approach, because a large language model output is sensitive to the prompts. So even if you change one word or even one character in the prompt, the output may be dramatically different. To understand the large language model, we can mimic it or we can compare it with the human brain. For example, human brain can have different regions. Some regions control motor, some regions control visual or linguistics. So for large language models, does the model also have some core language regions? To answer this question, the researchers retrained the language model with documents from different languages. They chose 6 languages and 100K documents from each language, and then they retrained the large language model. After retraining, they compared the model parameters with the parameter value before the retraining, and they took the parameters with the smallest change. The reason why they take the parameters with the smallest change is the parameters with the smallest value change are the ones which are already stable, meaning those parameters are learned well when we train the large language model in the first case. So by looking at those parameters, we can identify the core language region. So what is interesting is for the parameters in the core region, even if we change one parameter, it may severely deteriorate the model performance. Now let's look at a simple text completion example. So the prompt is Fudan University is located in. So if we take the 13 billion parameter Llama 2 model, the model can do the text completion task fairly well. So the university is located in Shanghai, and the model continues to output more history and information about the university. But if you take a parameter from the core region and increase its value by 10 times, the model output is gibberish. So for comparison, if you randomly take a model parameter and increase its value by 10 times, the model output still sounds pretty reasonable, even though there may be some factual mistakes. For example, here it says the university consists of Jinan and Kangqiao campuses. In fact, these two are not Fudan campuses. The takeaway from this research is mostly how we are going to retrain or fine-tune language models. For one thing, if you have a small amount of data and you train with multiple epochs, you may overfit and cause the core regions to change, and this will result in a failed model. Secondly, in fine-tuning, in addition to our own domain-specific data, suppose you want to fine-tune the model for your own cancer data. In addition to your own cancer data, you might also randomly sample from the original training data and shuffle these two sets of data so that when we fine-tune the model, the parameters doesn't drift away too much, and the core region remains intact. So we have finished the modeling section. Now let's look at the inference and tooling section. So I'm gonna skip over the training and inference infrastructure and primarily focus on orchestration. So in orchestration, I'm going to talk about two systems. One is MetaGPT, and another is eBay Phoenix system. So the eBay Phoenix system was developed given the following motivation. When we build mini applications, we can use agent tool framework like LangChain. LangChain has a number of components. It has models, agents, memory, indexes, prompts, etc. Some components we already have in the company environment. For example, the company may already have their own TV stores, and they may already have their own internal search engines built using Elasticsearch or other frameworks. What we can do is we can build a system to leverage the components we have internally, and we can pipeline them so that the system will have an increased efficiency. Ultimately, they build this eBay Phoenix system. The overall system is config-based to make it easier for people to build large language model applications. And they make the evaluation super easy. Evaluation is one of the tasks people face repeatedly when they are building large language model applications, especially when they are trying to evaluate different choices of models. And the system make it easier to deploy large language model applications. The second application or the second tool I'm going to talk about is MetaGPT. MetaGPT is an open source multi-agent framework. It is a very popular GitHub project. So far, it has over 31K stars on GitHub. So what MetaGPT can do is it can act like your entire engineering department. Given one line of requirement, it can return the product PRD, the design, split the work into tasks, and ultimately it can return the code repo. Here's a video that I can share.
Today, I am eager to share a multi-agent programming framework, MetaGPT. In a word, MetaGPT enables you to establish a comprehensive virtual company and access a dedicated team of professional agents that are adept at handling intricate projects. For example, if you want to have your own software company, you may recruit product managers, architects, project managers, and engineers. In MetaGPT, these employees are all AI agents who can work together autonomously and finally generate a whole code repository. Let's see how it works. After the installation and configuration your LLM API keys, you can run the company by giving it a target as a prompt. Here I want it to create a 2048 game, for example. Here we can see our product manager Alice goes first and starts to write a product requirement document. Then Bob, our architect, starts to write his design for the structure of the game. More agents will join in and contribute to the project. Let's quickly go through this.
Now you probably have some sense of how MetaGPT works, and I would encourage you to download it and try to play with it to see what it can or cannot do. Now let's look at our first application, which is centered around productivity improvement. So in different aspects of our work, whether it's for writing a report, creating a PowerPoint presentation, or writing some software code, we can leverage the newly created AI tools. In this sharing, we are focusing around the tooling for R&D. The tasks are listed in the table on the left-hand side, along with the different tools we can use for each task. So for coding assistance, obviously there's a lot of work going on with coding assistance, and we can use GitHub Copilot to assist in code writing. The level of maturity is high. Next to it are two medium or medium-high maturity levels. One is test case generation. So GitHub has experimental projects like test pilot, from which you can generate test cases. The maturity level is medium. Another one is knowledge management or question answering. We can use chat PDF or Mandible to do such tasks. The level of maturity is medium-high. In the chart on the right-hand side, we are dividing into 4 quadrants. On the right-hand side, I'm showing the tasks decided by AI, and the left-hand side showing the tasks decided by human. On the top row, I'm showing the tasks with high fault tolerance. So there is some room for making mistakes. And for the bottom row, I'm showing the low fault tolerance tasks. So there is very little margin for making mistakes. So if I look at the 4 quadrants, we can start from the lower left quadrant with a green ticker on it. So the tasks in this quadrant are mostly performed by specialized models and tooling. For example, ASR and OCR, we have specialized models for such tasks. Then we go to the second quadrant, which is the upper left. So this quadrant relies on human decision making, and there is a high fault tolerance level. So we have benefited a lot in this quadrant. Companies are creating Copilot products for assistance. So the tasks in this quadrant typically involve some level of human guidance and human to provide the context. And AI will help in the process, and eventually human make the decision. Now let's go to the upper right quadrant. So this is where the AI agent lies in. So in these tasks, we provide the agent with a very simple context. For example, in interactive learning, so we provide very little context, and the agent will do a number of tasks autonomously. To the lower right quadrant, this is the underdeveloped area. Here we require auto agents. So in this quadrant, given the project objective, we expect the AI to split the tasks to do the execution and to validate and present present the final results. So this is less developed, and a lot of the work is in experimental stage. So you can see AutoGPT and MetaGPT all lie in this quadrant. So previously, we were talking about tooling to improve productivity. Another aspect of productivity improvement is organization and people. For organization and people, there is a great deal of difference between different orgs and between different people. But if we look at the more deterministic trend, so what is the deterministic trend of the capabilities of the model, organization, and people? So for the large language model, we know the coding capability will continue to improve. So these days, it may make mistakes on certain coding tasks, but with the new versions of large language models, specialized coding models, their coding ability will surely increase. For organization, the organizations need to transform from digital to intelligent. By intelligent organization, we mean the organization need to deposit their knowledge not in documentation, but into models, into vector databases, so that the model can retrieve those knowledge. Previously, the organization rely on processes plus documentation plus tooling, and in the future, it's gonna transition to a different phase, leveraging large language models with prompts which can ask the model to do certain tasks, and the data need to be semantic. So the semantic meaning of the data need to be more explicit. For people, if you look at people from the angle of the product requirement and tooling, so the people is what is in between the product requirements and the AI tools. So we have new product requirements, and we know the AI tools are increasing their capabilities as well. So the person needs to really bridge the gap between the product requirements and the tooling, and they need to have better design skills, and they need to have the proficiency in using AI. Now let's look at our second application, which is an interplay between large language models and search. There are two directions. One is we can use search to enhance large language models, and on the opposite direction, we can use large language models to enhance search. Here are the takeaways from the different talks on retrieval augmented generation. The first is the high-level design is common among different talks. The high-level design always starts with data pre-processing and document chunking, and then we embed each document chunk, and then use a retriever which can retrieve the document chunks. The large language model connects to the retriever and interacts with the retriever to retrieve the results based on the user request, and the large language model will output results to the user. However, for different data types, for example, for code or data tables, the design choice might be different for different components. For example, when we are dealing with code, often we want to have some text summary to explain what this code block is doing. And the text summary will be easy for the retriever to retrieve in the semantic space. And for data tables, we want to do it the same way and convert the data into narratives, so that we can use the retriever to retrieve those table results. In terms of retrieval, in the coding applications, because in the data repository we have, there's a lot of duplication. So the retriever want to optimize diversity as well, so that we want to retrieve more diversified results. Ultimately, to ensure the quality and reduce hallucination, we want to take a holistic approach. So first, we want to have the generation and evaluation. We'll evaluate either using large language models or using deterministic rules. So only the generations that passed our evaluation will be outputted to the users. Second, there is a number of different ideas which allow us to quantify the uncertainty of the generated text and verify the truth of the statements. So there are a number of different techniques. For example, self-consistency, or ask a large language model to do a reflection by itself, or as in the Facebook paper, they suggested a chain-of verification approach called COVI. And we can also use different tools. For example, we can use a Meta Toolformer or use Web CPM. The different tools can retrieve the results and can also do a step-by-step reasoning. So now let's look at our third application, which is centered around the Copilot agent. Interesting question here is companies have developed systems like search and assistant systems before the introduction of large language models. Now, given large language models, how do we leverage it in the presence of legacy systems? We can take Xiaobu as an example. So Xiaobu is an assistant on the phone developed by Oppo. You can view it as another version of Apple Siri. So it can do question answering, it can do conversations, and it can also perform certain functions on the phone. So there are three options. The first option is we continue with existing pipeline-based chatbots, and we use large language model when the chatbot doesn't perform well. So large language model is trying to fill in the gap of the chatbot performance. The challenge with this approach is in case of multi-round conversations, if a large language model kicks in the later stage, there's a lot of context that it needs to fill in. Option B is to disrupt the existing tech stack and replace everything with large language model. And the challenge is certainly there's a very high inference cost. And not all the tasks require large language model. So there may be some simple tasks on the phone which doesn't require large language model. Ultimately, they took option C. Option C is a compromise, and it relies on the query traffic split approach. So for the query, first we do a traffic split, and the one pass will use a legacy pipeline-based chatbot, and another pass when it requires knowledge-based question answering, it goes to large language models. So we need to build this traffic routing layer. There are challenges as well, especially in case of multi-round conversations. The traffic routing becomes more challenging. So in terms of AI agents, there aren't as many presentations on this topic as for retrieval augmented generation. It's likely because for a lot of the applications, the use of AI agent is still in experimental phase. People have different sentiment over AI agents. There are some visionary outlooks. For example, some presenters are talking about our shared future with intelligent agents, how we are going to coexist and form society with AI agents. But more presenters are talking about the challenges. For example, to successfully build AI agents, we require specific foundational model and fine-tuning for API calling to achieve the level of precision we needed. The multi-agent framework, like the one in MetaGPT, it poses more challenges. For example, the errors in the previous phase will amplify. So in MetaGPT, suppose we start with the product manager writing the requirement. The errors in writing the product requirement will be propagated to the future stages in assigning tasks and in the software engineer agents coding. With a multi-agent framework, it's often hard to locate the problem and fix the problem. And we can only tune the prompts. So the results are more like a mystery box. So we just hope, given the prompt, the results will be what we aspire it to be. So the multi-agent framework, as far as right now, it can still be used to solve simpler and well-framed problems. But there are some challenges in solving open-ended problems. Now let's take a look at application platform. So this is from a sharing by a company building local marketplaces in China, and the name of the company is called 58. So their platform can be divided into 3 layers. So if we go from the application layer, in applications, we saw 3 interesting applications. One is to generate videos for users who write posts. The posts can be converted into videos, like the recruiting or looking for jobs, or looking for handyman. Another application is user reception. So when the user goes online, we can have a receptionist, a virtual receptionist who can greet this user and guide the user to where they need help. And the third application is post creation on user's behalf. A lot of the posts are routine posts, like people may want to send out a similar post every week. So this can be automated and can be done with AIGC. The next layer is a vertical layer. So we need to build vertical models for different application areas. For example, recruiting, real estate, auto industry, local services. For the different vertical applications, we need to build models specifically for those verticals. Now let's take a look at the overall summary and thoughts after going through so many presentations. I'm listing the summary and thoughts on this page. So first of all, different scenarios may have different requirements. Some requirements require a very high level of accuracy, like in medical or financial applications, while some applications have high requirement on creativity. For example, if you are writing a novel, so the creative tasks have pretty low or not as high requirement on the generation accuracy, but there's a lot of efforts needed in iterating on the prompts, so you can get the desired novel or the desired video. For question answering, we have high requirement on the accuracy, and often the system needs to be knowledge enhanced. For summarization, especially when we want the model to summarize a domain text, like a text for some domain literature, then the model is better to have some domain knowledge, and often we need fine tuning so that the domain knowledge is instilled into the model. For assistance, we need to be able to call APIs, and we also need to have a formatted output from the model. The second observation is large language models cannot substitute traditional AI systems in the scenarios that require high precision. But they can be used to improve certain modules, especially if we can break down the entire system into modular components. So for the specific models, we can either use large language model to improve the performance, or we can use large language model to improve the process of how we design those modules. And there might be have an effect on improve the efficiency or reduce the cost. The last observation is in China, there seems to be more passion on domain-specific large language models compared to US. As the domain-specific large language models, they are closer to domain applications, and thus they are closer to money. To build a good domain-specific application, we need to have the domain know-how and the AI know-how. We need to have the domain experts who know more about the domain and what the different players or the different customers care about in the domain. And we also need the AI scientists and machine learning engineers who know about the mechanism of large language models and mechanisms of how to do retrievals, etc. All right, so this is all about my sharing. So it's trying to scratch the surface of what this machine learning summit talked about, trying to summarize 50 presentations into one coherent talk and putting them into the same framework. Certain research findings may or may not be true, or they might be they might be revised by future research scientists. But just let me know if you're interested in any topics, and we can dive deeper into this topic. Thank you. Bye bye.